We can get started as folks trickle in. We'll get to the meat of the content. So it's so nice to meet you all. My name is Sudarshan Sampath. I am a product manager here at Unstructured. I own our core engineering and platform. I'm here with Jenny Wu, a solutions architect. Jenny, you want to give a little bit of background?
Yeah, I've been at Unstructured for about 3 months now. I'm really excited to be working on the super cool product that we're going to demo to you today. I've been in the tech industry for about 10 years, started off as a software engineer. Then I moved into solutions architecture at one of the larger cloud providers, and joined Unstructured just very recently. Looking forward to share a little bit more about what we can do, and show you our product.
Thank you, Jenny, and we're delighted to have you. So we have a great presentation and webinar for you. And as folks start to trickle in, let's talk a little bit about the agenda. Um, so what we're going to do, we're going to talk about opportunities and challenges as it relates to the generative AI production stacks and why your data is a goldmine and why it's so hard to leverage it in generative AI applications. We're going to talk about unlocking document potential, how we unlock the value of your human-generated documents, and the really interesting flywheel that's occurring in the generative AI space with the advent of these large language models. We're going to talk about powering Gen AI with unstructured data. That's where the majority of your insights and generative AI power is coming from. So, like if you're thinking about unlocking the value of unstructured data within your company, this is where we'll really get into the meat of how to do that. We'll talk about maximizing product impact. How do we increase the value of the data products you're creating and, frankly, the applications you're building on top of your generative AI stacks? And then I'm going to hand it over to Jenny for a live demonstration. And after that, we'll do some Q&A. And so we'll do like a demonstration of the platform. We'll do some code level programmatic access work, and you'll see a little bit about the power of the Unstructured platform. So some housekeeping. Chat goes into the chat. We have it muted for all folks. You can't just come and talk to us directly, but we will have Q&A, and we'll be happy to do that. We have over 1,000 participants in this webinar. So I think it makes the most sense to keep the Q&A towards the end. That's the question and answer box. We'll either try to answer it live or in writing. Jenny, you'll be helping me, and I'll be helping Jenny when she's doing the demo, but we'll be tag teaming those questions together. We're recording this webinar. So, you used your email to sign up, you'll get a recording of the webinar. And if you want to go even further, you'll see Jenny's amazing demonstration. You'll be wowed by her technical expertise and in-depth knowledge of our production stack. You can schedule a guided one-on-one. So you can see the demo again, you can see it with other documents, you can learn a little bit more about how to use Unstructured with your company and your generative AI stack after the presentation. And so we'll have links and guidance as to how to do that. And so with that, we are 4 past 10 a.m. PST. So that means I'm going to get into our presentation. So a little bit about Unstructured. So our reason to be is that we help organizations transform their complex unstructured data like PDFs, PowerPoint, HTML files, Excel files, images, whatever it might be, into formats compatible with LLMs so that employees can chat with their internal data. I actually really dislike the term chat. I think we're moving way beyond chat. We are providing the raw, consistent canonical output that is going to be relevant to your company as they explore generative AI and, frankly, artificial intelligence use cases, right? So all of the paradigm is like through the context of like ChatGPT, that is years ago. Like now we're talking about agents. We're talking about, artificial intelligence assistants that are helping you build code, right? Helping you create things, helping service your customers. There's so many different ways that you can leverage this data, but the key is getting that data into an LLM ready format. We have 10,000 paying customers. We have 20 million product downloads. We started as an open source company 2.5 years ago. We have 60,000 organizations using Unstructured, including most of the Fortune 50. And we have raised 65 million in fund and since our founding and funding since 2022. Some of the names that are backing us are Menlo Ventures, NVIDIA, IBM. We have partners like Microsoft who are looking at us as their Pegasus in their Pegasus program, which is sort of identifying the startups and companies that are really pushing the needle in the generative AI space. So it's a really exciting time to be here. And I think I speak for both Jenny and myself, we're very excited to share our product today. So what's the opportunity? Well, great data products demand a ton of data. And you probably have heard this, in the training data sets for ChatGPT and Anthropic and all these large language models, they require a ton of data to learn and actually develop the different sorts of relationships as you go through the neural networks and these large language models. And so like some of the examples that we've seen through customers that we're talking to, which large corpuses of data that are very unique to their space are things like pharma and life sciences. I spoke to a company, I think a week ago, that was looking at their research papers that had genomic strings, and they wanted to parse out genomic strings and figure out like, oh, how do these genomic strings relate to protein strands, and how can they create a database of that information and then leverage that. You think of the banking and financial services, a heavily regulated industry. How do they parse all of their transaction data? How do they relate those transactions to locations? How do they have that from like your mortgage statement into a database, right? So like a letter that's talking maybe about forbearance or perhaps nice things like mortgage applications. How is that stuff getting parsed and translated to a structured way? And then in manufacturing and industrial context, you could think of things like CADs, which are used in architectural designs, general machinery. I spoke to a car company. It was really cool what they were doing. They were taking car manuals, like old car manuals from like the 1980s, and then parsing it through our product so they could create a database. And then they would then use that database to help like car mechanics so that they would have an easy access to different types of manuals from like makes and models like 20 years ago and like vintage stuff. So it's like super cool stuff of this unstructured data that we need to structure, right? And create some ways to provide relationships to humans to actually like take, interpret, and use this information in their business contexts. So the problem to solve, the LLMs that you're leveraging are only as good as the data they're trained on. And 80% of your data is trapped in the unstructured file types. And every file type that I mentioned requires its own bespoke processing pipeline. And homegrown solutions are too brittle for production. We call this the rat's nest. And we're actually going to go through a diagram and an example of where this occurs. And you might have seen this in your own companies where you're building a lot of these bespoke pipelines and data processes, and they don't very interact or integrate together very nicely. And it requires a ton of time and expertise to build production pipelines. And so 20% of the world's data is structured, and those are things like tabular data, like the base example would be like an Excel spreadsheet, but like really, any sort of like relational database type data. But 80% of the data is unstructured, right? Obviously, we think about the, code is unstructured data in some ways, audio, video, your PDFs, memos. I'll give you an example of unstructured data that I created today. I had a meeting this morning and I took notes. And those notes are actually informing some product decisions I'm going to be making later. That's goldmine. That's like us building our IP here at Unstructured, and it is locked currently on my Notion doc. It is not available as part of like an LLM that's queryable, so that, God forbid I get hit by a bus, the product manager takes over for me, they wouldn't have that context out of the box and wouldn't be able to find the information easily. And that's the challenge, right? Getting that information from your company's unstructured formats into structured formats that are easily queryable. And so the generative AI compounds this challenge. And this is the piece I was mentioning over at the outset of our conversation or the webinar, is that unstructured data has hockey sticked. And this is an enterprise engineering leader within the life sciences. He told us with generative AI, we've generated 10 years worth of research docs in the last year. So what does that mean? Not only is there a 20-80 split in terms of the world's data and from structured and unstructured data, that 80% is growing exponentially faster than the structured data of the world, right? And this makes so much sense, right? As you have, big folks have kids. My cousin is in college, and like all he does is go to ChatGPT and ask ChatGPT to write his research papers. And I'm just like, I don't know what the point of college is at that point, but if that's what you're doing, you can do that. But it's generating his research paper, and he's using that information to write a research paper, and that is part of the corpus of intellectual property of humanity, right? We're adding to it exponentially. And that creates a really interesting strain on data teams to deliver ROI. Data science and ML teams are unlocking huge value through things like vector search, RAG apps, tuning and training models. That creates additional pressure on the data engineering teams, right? Your core engineering teams that are shoveling and moving data from one place to another, structuring it, and they have to productionize this data to realize value. And that's what is creating this bottleneck. And I think we're at this inflection point in the generative AI story where we've done a lot of the science fairs. We've proven a lot of the value. It's very hard to productionize that value, right? It's very hard to create a product that is a flywheel, that's self-sustaining. And that's what Unstructured is here to help solve. So this is what I was mentioning at the outset, the rat's nest. This is the typical enterprise workflow. Hopefully you can see my cursor, but before generative AI, you had a system of record. You had a couple of upstream connections. So it could be like custom code, Airbyte, whatever it might be. And you have some database. And that's what you're doing. You're moving from data from point A to point B, and you have these connectors. With generative AI, you now need to undergo file transformation. How do I get information from a PDF? So you're now doing like extracting file text parsers, OD, OCR combo models, VLMs, multimodal models to extract information. You then need to do tuning around the prompts to get that information. You then need to do document cleaning, regex, to create a canonical consistent schema, because the schema has to be joined to the structured data, otherwise it has no meaning from like a query perspective. You then want to chunk it. You want to create embeddings against those chunks. The embeddings provide the vector dimensional space so that your RAG application can actually search and find that information at a faster retrieval time. And then you have to publish it to downstream connectors. And what companies are doing is they're doing this piecemeal, right? Like they didn't know that they needed file transformation. They didn't know that they needed chunking. They didn't know that they needed document cleaning. They didn't know that embeddings were incredibly important. And so you start building each of these pieces in isolation, right? Each one of these verticals are being built in isolation, and it creates a lot of noise and a lot of engineering overhead to create what should be, and like none of this has to do with like the core value prop, which is I'm trying to build an application for my customers, and you're spending all this effort in getting your data there. You haven't even gotten to the foundation, and we're trying to help build that foundation with you. So this rat's nest zaps your engineering talent. The effort and user delight are misaligned. That's our core belief, and that's why we have the product we're going to be demoing. Don't ask your ML engineers to build data pipelines. That's like not the best use of their time. What you want to do is leverage like consistent canonical schemas so that your teams are just using what we use. I use the term turning on the water. And it's a term I used. I was at Amazon for a long time before I joined Unstructured. And I used to make an argument to the VPs. It's like, you guys don't actually care about the engineering plumbing that powers AWS. You care that your customers are able to access a cloud environment, or they're able to leverage SageMaker, or they're able to leverage these products. Like, what we need to do is to invest in that plumbing, so that all you have to do is turn on the water. And then once you have water, you're able to do all these amazing things, right? Like as a source of life, I like thinking about that in terms of data. Like data is your water. It's going to power and inform everything else you're doing. And so generative AI at the application layer is your P0, right? Your skilled players should be building next generation features. Models and tools are changing by the week. You want your team focusing on the models and tools, not focusing on this data, not focusing on the rat's nest. And so we estimate that on average, it takes about 30 engineers to maintain and build at scale. And that's from interviewing a bunch of customers. We spoke with a very large model hosting company that has 45 engineers doing what we're doing right now. And we're actually in the process of ripping all that out and replacing it with Unstructured. We think that a lot of the effort needs to be redirected to high impact user focused features. And this is like really passionate to me because sometimes I talk with folks, I live in Seattle, so like I'm pretty big, not big, but I talk to a bunch of people in the Seattle tech community, and they're like, oh, like I'm not sure like AI is going to be this next big thing. Like I don't think there's the ROIs there. And my point to them is that the ROI is misaligned because it's all being invested to get the foundations right. Like people aren't building the high impact user focused features, and we want to help unlock that by providing that foundation. In general, we estimate across the 10,000 customers that I mentioned that we've saved them about $1 million per customer in engineering hours. And then we would expect that $1 million to be invested in innovation, such as new user features, as we discussed. And generally, when I think about the platform, my pitch is that I try to get 3x ROI. Like for every dollar you spend with Unstructured, you're getting $3 back in terms of the return on investment. Ideally, we get that to be more, 5, 10, 30x. We want it to be a delightful, easy experience. And I hope once you see Jenny's demo, you'll see that too. So the solution, what's needed right now? We need to unlock data and unblock teams so that those teams can build powerful user-facing features using generative AI properties and technologies. We need a persistent, repeatable, canonical experience, right? So like of all your different data sources, if it's audio, video, PDF, Excel, PowerPoint, whatever you're providing, we need to provide like a static schema so you can build an application on top of it. And then you want native integrations that partner and not replace your stack. You've put a lot of work into your ETL. We integrate seamlessly with your ETL. And if you think your ETL is not good enough and you want to reallocate those resources, that's fine. You can use unstructured as your ETL solution. So where do we fit in the data stack? So this is the unstructured data. As I mentioned, 80% of the enterprise data is unstructured. And what we'll dig into here is the unstructured platform. We're to the right of your data source. And there's a really great comment in the chat. I just want to mention it real quick. A canonical experience is a consistent schema. That's what I mean. So like no matter what data you provide to us, we guarantee you a unique key combination that is joinable by your structured data. And that is what's going to provide the base layer. And you'll see that schema and that canonical experience when Jenny goes through her demo. That's a great question. Thank you for asking. But unstructured sits to the right of your data stores and to the left of the vector stores, your knowledge graph, and your fine-tuning platforms. So we provide the canonical experience as an output, that JSON schema, and you can then use it to store into your vector store to leverage for fine-tuning models or to use in a knowledge graph. So I want you to think of unstructured as Grand Central Station. These are all of our source connectors, the sources of data that we can pull from. These are all the file types. In fact, it's not even all the file types. I couldn't fit all the file types on here, but these are all the file types that we can take and manage and structure for you. So we take all of this information from all of these sources, we put it through Unstructured. We have transform strategies such as Basic, Advanced, and Platinum. So as you use Unstructured, and there are other companies in this space who do this type of like file transformation to get canonical experiences, a lot of them will like always tilt towards like VLMs and like really heavy duty models. That is not the right thing to do. If you think about like a PDF, imagine a PDF in your mind that's like text, images, and tables. The majority of the content in that PDF is text, and it should not be go through a VLM. It's very expensive and it's very, very slow. So we use a concept known as ensemble parsing to use object detection models to first understand the content that is in a document. We then strip out the text and send it to our basic. We'll strip out tables and send it to our advanced pipeline. And for really complex images, such as the genomic sequence I was mentioning earlier in the presentation, we'll send it to our Platinum fine-tuned VLM. We then extract all that information. We use custom third-party integrations such as Amazon Bedrock, Together AI, other forms to get embeddings, enrichments, whatever we might need to do. And we'll stitch it back up into this. This is the gold mine. You're looking for this JSON. We'll chunk the JSON with embeddings and structured data and custom integrations. And this is the output. And then you provide us a destination connector, and we'll deposit it. And our guarantee is that this is always consistent. This is what you're going to build your application on your destination connector. So we have a superior transformation. We integrate with any model for superior transform. This is like a really big step for us as a company. It used to be that Unstructured thought of itself as a transform company, that we were just focused purely on transform. We think we're beyond that. We think of ourselves as Grand Central Station. And this is like a really important product or like company milestone for us because it made us realize that our companies need, our customers and their companies need to be able to use our product in a variety of different modalities. So imagine this complex PDF, just like I was describing. There's text, there's image, there's a table. It'll go to the Unstructured platform. The text will be extracted, the photo will be identified, the table will be analyzed. We leverage OCR and post-processing to get the text out. We'll use a multimodal image to get the image out, and we'll use table processing to get the table. And we're able to stitch them all together into the canonical JSON. So here's like a concrete example of what would happen. And then you as the customer can actually choose like what level of precision you want. Like you can choose a more expensive VLM model if you wanted to. You can choose a different model for table processing. You can choose a different model for your text parser, although our text parser is lightning fast. And so I would recommend it. And I think it's very, very good. But you'll always get this canonical JSON out of our platform. And so the goal here is that you choose what's best for you, right? You can optimize for cost, you can optimize for speed, you can optimize performance. We do have recommenders that are coming out in the platform in the next week where you can just click and say like, hey, choose the best optimized strategy for chunking, or choose the best embedding model, or choose the best cocktail of models for speed or performance or cost. But there are different personas leveraging our product. Typically what we see in the platform is that technical users will first do a couple of tests using our what we call easy button strategies, which sort of do have some preset defined filters to them, and then they'll actually go in and make a what we call in our ETL workflow editor, excuse me, where they're actually editing uh, the DAG workflow and like making adjustments, choosing their models, and figuring out like the exact type of specifications they need to do. But we'll all walk through that when we go into the demo. And then the other piece that I wanted to mention is that this is going back to like kind of where we are in the inflection point in generative AI, is that it's changing all the time. And we're trying our best to stay on top of the changes, but one thing that we are going to launch by the end of Q1 and in fact into early Q2 is this idea of a plugin marketplace. And so this is a screenshot of our platform. You'll see more in depth of what it looks like when we go through Jenny's demo. But we designed our platform to be a set of plugins. And so that's code wrapped in a container. And the plugins are authenticated against their data plane. And so it's only a no-code platform when you're in the UI. Everything is executable through Python-based modules known as plugins, but even that Python thing could be abstracted. You could leverage any language. You could use Ruby on Rails. You could do Scala. It doesn't really matter. It just has to be executable through our plugins. And we want to relaunch a plugin marketplace. And so what does that mean? It means we're going back a little bit to our open source roots, where we're allowing the community to contribute plugins. If you guys have a really great model you want to use with Unstructured because you want to leverage your canonical JSON, or if you have a really custom integration that is like only specific to your company, coming from Amazon, that actually happens all the time. Like there were a ton of products that are Amazon internal that you've never heard of that power everything about that company. Like you can use that code in our product through this plugin architecture, and I'm really excited to share that a little bit later in the quarter, hopefully for release in early Q2. And so once you have that idea of plugins, well, maybe you're asking, well, how do I use this product, right? Well, so we have the SaaS product. Jenny's going to show you a little bit about that and go through that. We can deploy it on any of the major hyperscalers. Generally, the only thing that we require is Kubernetes. So you can either do bare metal. Many of our enterprise customers, they're very precious about their data, as they should be. And so we actually recommend like, hey, like partner with us. We'll launch it in an VPC environment, launch it in your Azure, AWS, GCP environment, do a bare metal deploy. We can do it IO bound. And then we manage it all through Helm and Pulumi, Pulumi being our infrastructure as code platform. Helm charts doing all the management of the Kubernetes pods being spun up, underpinned by Kubernetes. The only thing that's a hard requirement generally to us is that there's Kubernetes. And even that we could be flexible on, but Kubernetes is really easy. And so if you're not on Kubernetes, I highly recommend that you try it out because I think it's quite easy and pretty cool. And so with that, we're going to go into the demo. Let me talk a little bit about what we're going to see in the demo. One, we're going to build the foundation. So we're going to talk a little bit about how we build the foundational data stack through an ETL pipeline. And Jenny's actually going to walk you through building an ETL pipeline in the platform. And it's going to be feed into VectorDB. And she's going to show you a simple RAG app in real time. We're going to optimize for efficiency. We'll talk about the partition strategies a little bit more, balance of good, fast, and cheap. We'll talk about transforming documents. We'll transform a couple of different documents to deliver really great JSON output. And you'll see a really cool side-by-side of a complex image and then like what it's actually doing in our product. And we'll talk a little bit about how you can save time using Unstructured. I think Jenny will, she'll talk a little bit about how long it took her to put this all together. And you think you'll be shocked. And so with that, we're going to go to the demo. I'm going to give up my screen sharing. And I think it's for you to take over, Jenny.
All right. Can everyone see my screen? Sudarshan, verify that you can see it.
I can see your screen.
Okay, great. I'm actually going to get started with where you would land when you first get started inside Unstructured. So if you're interested in signing up just to see what the platform is like, on the first sign up, you get a 14-day free trial and 1,000-page limits of transform per day. So you just visit platform.unstructured.io, input your email address. It sends you a magic link into your inbox. Click that link and then you would sign in. And this is what the platform looks like when you first visit. We have a quick start video that walks you through how to use the Unstructured platform, what each of these things do on the side, as well as documentation, blogs, our Slack community, and we welcome feedback after you try it out. So what are we going to do today, right? We're going to walk through how to create connectors and destinations and sources to grab and write data. The next thing that we're going to do is look at how to do a transform and get the canonical JSON, as well as add more enrichment later on. And then lastly, monitor monitor the workflows and the jobs to make sure that things are moving along correctly. So what does a connector look like, right? We have both sources and destinations, as Sudarshan has mentioned. When I go in and set up a connector, essentially I can click on create new connector, and we support over 50 source and destinations. Give it a name, select the provider, and then once you click on continue, it will ask you for some credentials that you would need to set up. And so if I say, for example, wanted to create an S3 bucket, I would give it my bucket URI, and then provide my authentication. I'm not going to do this on the webinar, given that it's recorded and I don't want to give away my access keys to everyone. But what I've done is I've already set up my S3 bucket with source files that are all living in here. And I've validated that Unstructured can go and read from source. And the same thing with destinations. You set up a destination connector in a very, very similar way. And for the purposes of the webinar, we actually spun up a vector database inside Astra DB. And so this is provided by our friends over at DataStax. And I have a vector database here as my destination connector. And so now that I have my source and destination, what do I do with my workflow, right? So you go into the workflows tab, you can click on create a new workflow, and you have two choices. You can either build it yourself, which allows you to control every detail of the workflow itself, or you can choose the easy button and select build it with me. And so inside the easy button, you create a workflow, select a source, and then select a destination. Move on to continue, and then we have a few different ways for you to do transform. So our basic strategy, this is where we just strip out the text, and from the text, you're getting super fast transform where we'll grab all of the text. It's very, very cheap to do. The next thing that we have is our advanced strategy. And this is really useful for files that have images or tables, or files that are in PDF that require some sort of OCR or object detection. And what it does in the back is we have a model that runs either in CPU only mode, or you can choose to use GPUs if you have GPUs available. And it goes and it detects objects around what each piece of the file looks like. And so to show you how this actually works in practice, this is one of the example files I will be showing in the demo. The object detection model goes in and recognizes, hey, I have a piece of text here. I have another piece of text here. And hey, I have an image here. And it starts labeling these objects so that when we pass it through the advanced transform, you get this JSON element, and it tells you what type of element is in the document. And then we have our platinum transform strategy, and this is for the challenging documents that Sudarshan had mentioned. So our friends over in life sciences trying to understand RNAs and DNAs, and how the helixes are working, the sequencing of that, and then mapping it to proteins, they would be using something within the platinum transform, where we're passing the pieces of information to the visual language models, and then trying to get descriptions and interpretations of those images back. And of course, you can do custom transformation where you select your own strategy. And so fast, high res, and VLM corresponds very closely to the basic, advanced, and platform transforms. And then there was a question in a Q&A about enrichment. So we do have enrichment options available where you can summarize images, and out of the box, we have OpenAI as well as Anthropic Claude. But if you wanted to bring your own model, we can support for that as well. Same thing with table summaries. From here, you can choose to include the page breaks for the output or infer any table structure. And then we also add an option for you to exclude pieces of text that you didn't want in the output. And then from there, we move into chunking. And so we have chunking by character, page, title, or similarity. And you choose the chunking strategy that works best for your use case. And then lastly, we have embeddings providers. So you can choose Azure OpenAI, select the model, or you can choose something from Together AI and select an embedding model from there. This is what the build it with me workflow steps look like. Now, I've already built out this workflow, so I can actually go and open it up, and you'll see here that we have a DAG that you can use to visually play around, set up your source connectors, make some modifications here if you needed to. So I can choose the source and then choose my partition strategy. And of course, this goes back to our ensemble partitioning that Sudarshan had mentioned. So if you know that you have a corpus of data that's text heavy, we suggest that you choose the fast strategy. And then of course, based on the sources of documentation that you have, there's different partitioning that you can use. And we're trying to optimize for price performance. Of course, the recommendations feature that's coming out very, very soon also would help you select partitioning strategies, as well as choosing the best chunking and embedding models based on the corpus of text that you have. Here I have my ability to do the enrichment. So the same thing as what I was showing inside our Build It With Me workflow. You can choose to configure it inside the DAG as well. Once you've completed your workflow, you add a destination connector on where you want the JSON to go or where you want your embeddings to go for vector databases, and then click on Save. And then from there, you would just click on Run the Workflow. You can either choose to run it one time, or within the workflow configuration, you can actually schedule it as a cron job. So run it in a time-based format. So like you can run it every 15 minutes, or if you wanted to run it on a monthly schedule. Then a job gets kicked off and you can monitor each of these jobs and look at, well, how many files were structured and where is each file in the process. And so the really neat thing is that these workflows actually have an ability to look at what files have been changed. So each time I click run, it's picking up only on the files that have been changed. Of course, if I didn't want to only do change files, I can make sure that I can reprocess all the files, and in which case it would pull all of the files that I have in source and reprocess everything. But again, that's going to be a little bit more costly. So I've kicked off the job. It'll give a status that says pending, and we can watch as it goes through each step in the workflow. And while we're waiting for that to run, I'm just going to quickly show you some of the files that we have for Transform today. So I pulled the paper on agents and how that works with generative AI that Google published just in September. You can read information about what is an agent, and then there's a couple of things in here. So you can see that there's figures that explain the agent architecture, as well as tables that compare agents to models. We also have some infographics on living with coyotes, how to get them out of your backyard, what they feed on, cat breeds, what these cats look like, some dog breeds, and what their features are. And then last night I pulled the latest release of the shareholders letter for the Netflix earnings call. And today in our reg demo, we're just going to ask some questions about Netflix and how it's performing. And you can even see our table transforms. Here we have a very, very difficult image. It's actually, there's no text that can be pulled from this image. You can see that my mouse is scrolling over and I can't grab any text. It's just a scanned file. But you'll see that we can actually transform these types of images as well. And lastly, I have just the 10K filing from 2023 for Netflix. Okay, so here, so inside my transform, I showed you in the UI how to do this. Now let's look at what we would do in the code. So our platform is supported underneath the hood by our software as a service API. And our API then allows you to choose different types of partitioning similar to what you saw in platform. So here in my code, I just want to process all the files I have in my input folder. And then I give my partition config right here. There's a couple of strategies that you can choose, auto high-res fast or CR only. And then we can choose our high-res model name, which is the model that we use to draw these bounding boxes that we'll see. So the model that goes in detects that this is title, and then a menu table of contents, or detects a table. And that's configurable inside the partition config as well. We can select table types to skip inferencing on. So file types would go here. If I wanted to split my PDF pages, and then the concurrency level of like how many PDF pages do I want to run in parallel. The type of image blocks that I want to extract, my language that the files are going to be in, and then also the chunking strategy. And then from here, essentially, I'm just making a call to our client, so the unstructured client, and then making sure that it's partitioning based on my config right here, and then process everything from my folders and then save it as a JSON in my output folder. So this is what I've done. It's super simple code. We can definitely share this after the webinar, but let's do a comparison between the input of our files and what the transform actually did. So I'm just going to open this up to the side, and you can see that this is the output of our JSON. So I'm going to pretty it a little bit to make it easier to read. Now, in the webinar, this is still very difficult to see, right? Like I can zoom in, but JSON is hard to interpret when we're looking at it. So to make it easier for all of us, what I've done is I've converted this JSON into Markdown so that we can render it. But inside the JSON, I did want to point out that you'll see where we've identified the title as agents. We have narrative text that talks about the authors. And then where it's coming from, this is a paper published by Google, and then the image of the agents. So what does this actually look like in Markdown format, right? Let me open up this, and then we'll just do a quick preview. Okay. And so we can do a side-by-side comparison. This is the markdown that got pulled out. We have acknowledgements, and then again, a table of contents with the image. It interprets the image. So image shows a table of contents for a document about AI agents. And then our table of contents gets extracted. But what I did want to show is this feature right here, where we have a figure one that explains this general agent architecture. So let's go to figure one in our markdown and take a look at what we see here, right? We have this image element, and it was interpreted with our Anthropic plugin. So this is the enrichment that happened. And it shows the architecture of an agent runtime system, right? Showing the flow of interaction between a user and an agent, as well as the internal components. So this is the description that we have for enrichment. Now I have very similar things that I've done with the other files. So if I wanted to take a look at our Living with Coyotes file, let me just close. And then on this side, let me open up our Coyotes document. You'll see here that, again, we strip out all of the images as base 64, and then we grab the text that is part of this document itself. And so that image that we had earlier, where it was really difficult to read and pull out text from, what does that look like in our transform? So let me pull that up and we'll render the markdown. And then let me close this tab. Drag this over. So you'll see that we have this image element with a description, right? It's a vintage advertisement for the Hennessy Reserve Cognac. It will show you the top half of the advertisement, as well as the bottom half of the advertisement containing marketing text, which promotes the cognac and then emphasizes quality and origin. And then you'll see here that it's actually pulling out the text. So I've gotten unextractable text and I convert it into text here. So inside our JSON element, we actually have that data, right? All right, so now that you know what the transform comparison looks like, let's go back into our RAG application and ask it some questions. So again, I've created a vector database inside DataStax Astra. These are our very close friends. And then what I've done is I've created a RAG application with the Langflow offering that they have, where I have chat input. It then converts the chat input using the OpenAI embeddings model. And again, this embeddings model we had selected with our workflow. So if I go back and open up the workflow, you can see that I selected text embedding 3 in my workflow embeddings model. And so inside Langflow, I'm using the same embeddings model just to retrieve convert that text into embeddings and then try and grab the vectors that are in the vector space inside our vector database in Astra. Then I will parse that data and then provide it a prompt. So it's a really simple prompt, just given the context above, answer the question. And so from here, then we're making calls to our OpenAI, and you can select different model names, but what does this actually look like in our playground? So this is the chat application. Going back to what we see with our coyotes, right? I want to ask questions about this coyotes. And a question that I'm asking here is, what is the primary diet? You'll see here that it answers, okay, primarily feeding on mice, rats, ground squirrels, gophers, rabbits, and carrion. How do I know that that's actually coming from this PDF file? So let's just zoom in a little bit and look at what it's saying, right? We extracted this text, and then you'll see here, the primary diet of the coyote consists of mice, rats, ground squirrels, gophers, rabbits, and carrion. This is word for word being pulled from the text that we had extracted from the PDF and then written to the vector database. And then again, if I wanted to ask questions about the Netflix shareholders letter, let's take a look at what the transform output looks like. So let me just close this markdown here and then open up our shareholders letter, right? It's pulling out information about 2024 projected growth. And I have a table right here. What does the table look like? Let's just scroll down right here. In millions, etc. So it's correctly identifying table headers. And then same thing with all of the information that's part of that table. So now let's go and ask it some questions about this shareholders letter. So if I go back to our reg application, what was Netflix's revenue growth in 2024? Ask this question. Inside the reg application, it's going into the vector database, pulling out relevant information similar to the question, and it'll provide an answer. Okay, 16% year over year. Let's see if we can go find that in the document. Okay, for the year, revenue grew 16%. And so it's pulling this word for word from the document. All right, so that pretty much wraps up the demo of the product. And again, it was so easy for me to actually do this, right? I wrote this code in like less than 15 minutes and then did a transform. Earlier at the beginning of our webinar, there was a question around like tables that expand multiple pages. And I wanted to just quickly go back and then touch on that a little bit. So when we look at partitioning and selecting partition strategies, here is where you start to think about like the type of document that you have. And so if you have a table that is spanning multiple pages, you probably want to choose something that is a little bit more consistent with the files and the information that you have in the file. So the fast strategy would just strip the text. The high-res strategy would be the one that to recognize, okay, well, these things are tables and they're spanning multiple pages. And so what we can do after creating this is making sure that we have enrichments of the tables. And if you didn't want the enrichment, you just wanted the text, that's fine too. And then inside the chunking strategy, you want to select the right one. So if you chunked by page, then the table would be broken up by the pages. But if you chunked it by title, there's a higher likelihood that the chunking strategy would recognize that these tables are part of the same title and then just I stitch those things back together. And then from there, you would go into the embedding strategy. Okay, so what did we show you inside this demo, right? I showed you the UI version of platform. I showed you the transform quality of unstructured transform. And then I went through how easy it was to do this with our platform API through code and using it programmatically. And to make it even simpler, we have a Swagger UI that contains all of our platform APIs. And so if I wanted to say, for example, go and list all of the sources that I have available, I can just click on source type being S3 and let's see what type of S3 sources I have, right? I'm executing based on the unstructured API key that I'm passing in. And essentially, it's just making a curl call in the background. And then here's the response, right? I have a bunch of different S3 buckets that are source. And so if you wanted to just play around a little bit with our platform API programmatically, you can visit us at platform.unstructuredapp.io/docs, and then that gives you this Swagger UI. And then you would just copy paste your API key in order to run all of these queries. So then the next question is, where do I go get my API key, right? So going back to our webinar workflow, if you click here and then just click on your account settings, it'll take you to a page where you can go and copy your API key so that you can run everything programmatically. Um, and then let's go take a look at our job that I just ran, right? It's been running for 10 minutes, and the reason why it has been running for so long is because I was trying to process on the fly one of the documents that was sent to us inside the chat. So it had 368 pages of tables, and we're just extracting that and sending it into a table form right now. Okay, so that pretty much wraps up our demo. I'm going to pass the microphone back to Sudarshan and then look at all of the Q&A that has come in while I was demoing. All right, stop my sharing.
Sorry, 1 second. I just need to get the slides back. Presenter view. Sorry, I was like in the midst of responding to a question, and then you got me right when I wanted to get back. There we go. So 1 second. There's the share button. And hopefully you can see my screen. We'll go full screen for this. So yeah, so to our Q&A, I apologize for that small little technical difficulty. So for the one-on-ones that we discussed a little bit earlier at the beginning of our presentation, please contact us at unstructured.io/enterprise. Contact to learn more about our no-cost guided proof of concept. That's where you have like one-on-ones and we can like set up proof of concepts. You can throw documents at us for us to process. We can take a look at it and share some of the tips and tricks to use our platform. And for the developers in the room, like please just take a 14-day free trial. We provide 10,000 free pages of transformed documents, so you can use it, hammer away at the platform. Feel free to reach out at our community Slack too. We maybe should have put a link up here, but if you go to unstructured.io, there's a link at the top of the page to join the Unstructured community. And then otherwise, let's open it up for Q&A. I do have a couple of questions that came in from before the webinar. So let's take those just to make sure that we're able to hit them. So the first one here is, what are some of the best practices for privacy-sensitive confidential documents, data, identity, financial, medical, and protected files? Jenny, do you want to take that one? I have like some concepts from like the platform perspective, but I'd be curious to know if you have a perspective, or if you want me to take it, I can.
Um, I was just in the middle of answering another question, so can you repeat?
Oh, I did the same to you. Oh my gosh. What are some of the best practices for handling privacy sensitive / confidential document data? And
Got
the
it.
examples here were identity, financial, medical, and protected files.
Yeah, so with the idea of data security being this thing that everybody is paying attention to for regulatory purposes and for compliance purposes, if you have any sensitive information that's in source that you would like to strip out during processing and then write to a destination without the sensitive data, we do have ways to add pre-processing as well as post-processing plugins. So the plugin architecture that Sudarshan had shown earlier. Um, there are also certain things that like we as Unstructured ensure that we don't have any visibility and written visibility to your data to go and like see what you actually have. So everything that you're doing inside the unstructured platform is actually done in an encrypted way. Like me, even if I had credentials to access the unstructured platform in the back end as an employee of this company, I wouldn't be able to go and access your environment with your data if you're a user of the product. So that's two aspects of security, right? The other portion that I did want to touch on is compliance. So if there are certain sensitive data that you're trying to identify from within source, we do suggest that you try to get to it as upstream as possible because you don't want that sensitive data to be passed on as you're doing transform downstream. However, there's also a consideration that you need to be aware of, whereas for your use case, maybe it's necessary to have the sensitive data be written into the vector database or wherever the destination is in order for that data to be useful, right? You need some way to tie that data back to like a unique identifier. And so there are certain things that you would need to put into consideration in terms of like architecting around your use case to make it both compliant as well as useful for the problem that you're trying to solve.
That's awesome, Jenny. I really appreciate that. I'm gonna just add like a couple of things that are more like at a generic level. Like outside of the platform, you can do things like masking. You can use things like K anonymity and other types of encryption, like ahead of time before going through the unstructured platform. By the end of February, we'll expose our prompter. And so you could use our prompter for named entity recognition. And then once you have that named entity recognition, you could mask it within the platform. So those are all options that you're doing, but just be warned that if you need that unique identifier, as Jenny was saying, it's going to be hard to tie back to your users. So like if you need that customer data, even if it is private, like in the medical space, you need to understand that like once you do that type of redaction, it can be hard to go back and tie back to a use case that you actually wanted to solve for. And sometimes like it's such a delicate balance, like to balance like usability and privacy. And so just be wary of that as you go through that process. Another question I have, and I can take this one, is how would unstructured be used for real-time document processing? Are there benchmarks in terms of performance and time taken? There's two parts to this question. We do have an event streamer. The event streamer is not available as part of our SaaS product. It could be in the future, but we're offering it now. If you do an MVPC deployment or you host a version of Unstructured in your cloud environment, we have an event processor. That event processor is compatible with AWS, GCP, and Azure. If you're in one of those cloud stacks, we can support that. And so what does that mean from like a real-time processing? It's an event stream. So it's identifying when an object hits the source, and then once that object hits the source, it has a warm job, and that warm job is skipping the index and download portion of the platform. It's immediately going straight to partition based on some pre-configured workflow settings. And so the concept of a job goes away. It's just like a workflow that's always in a perpetual state and ready to work and go through. In terms of latency and performance, that is entirely based on the types of documents that you're processing. Our text parser is milliseconds fast. I've seen it like sub 50 milliseconds for, hundreds of pages of documents. Like it's really good post the identification of the OD model. The largest time that our platform takes, 80% of it's on the partition step. If you're using a VLM, do not be surprised that it's taking 30 to 60 seconds in some cases to actually process that image. And that's why I just don't recommend that you leverage everything through a VLM. One, it's incredibly expensive. Two, it's likely overkill for what you need. And three, like it's just not going to be as performant. So it kind of depends on like what's being leveraged there. I mentioned there was a triangle in terms of like, speed, cost, and performance. Like you need to make those choices as to what you look like, or you can leave it to us to make the best educated guess. That sort of depends on your use case. Any other thoughts you have there, Jenny?
I do want to add on that in order for us to help determine the best transform strategy for the corpus of data that you have, if you have very large documents and you're struggling to figure out like which type of partitioning strategy you should be using, the documentation guides you through, like if it's text-based, use the fast strategy. If you have anything that requires table inference, then that's kind of where you implement high res. And then for the VLM partitioning strategy, for what it's worth, like Unstructured does not overcharge you on VLM processing. So we don't actually like add in additional charges to use the VLM, but we don't suggest you go through the VLM because it's unnecessary. And for like 90% of the use cases, you don't actually need the VLM. And so in the demo, I had talked about like when did I see customers actually needing to use the VLM and needing to use enrichments is when they were looking at DNAs and how the DNA sequences interact with protein sequences. And that is the type of challenges that you would go to the VLM for.
Awesome. Thanks for that additional context. The next question I have here from the pre-screened questions was, what are some of the best techniques for dealing with PDFs that have a lot of tables and a lot of data within those tables, or table that's a cutoff between pages? I think that's the beauty of Unstructured. We leverage these object detection models ahead of time so that we're able to identify those tables. We're able to group those tables together, and you just put them through our product and they parse. Jenny, do you feel like I'm oversimplifying it? But that's kind of how my experience is.
No, I think that was spot on.
Awesome. Thank you. How do you manage documents on an ongoing basis when they are edited or updated? This is an awesome question because it goes like sort of the fundamental business prop of Unstructured. The first time you build a workflow and Unstructured and you have some source of data, we process everything in that source. But we only do that once. For us, it's incredibly important to commoditize our ETL so we can embed it throughout your system. We want to be partners with you as you build and grow your generative AI applications. So to me, that means we have to be cheap. And the way that we be cheap is that we are processing the least amount of data to be effective. I want to go into a little bit of the technical background, but I'm not going to go too deep, I promise. When we take data from your source location, we identify elements. Those are the smallest atomic unit within your documents or within your corpus that we are able to identify. And those atomic units, known as elements, are tagged. And we don't keep any information about your documents, but we do keep a record of the elements that were generated and the tagging that's related to the elements. That means every time a new file is added or a file is changed, we're able to identify which elements are different from the previous run of the workflow. And that's how we know that the files change, and that's how we only process new and changed files in subsequent workflows. So workflow 1, we process everything. Workflow 2, we only add new or changed files. And then that's true from workflow 2 to workflow n, however many times you do it. We guarantee no duplication in your downstream connector. There is an option in the platform that says reprocess all, but you don't need to click it. But generally, we always upsert and overwrite. And that's just to make sure that we don't dilute the downstream RAG application. That is like really bad in like vector search. And so whatever you get is a unique element related to the documents that you're processing through our platform. Anything you'd like to add there, Jenny?
Um, I did mention that if you did want to like reprocess all, there's a toggle that you can have in platform for you to just pick up on all the changes. But given that most of the time you only want to look at what has been changed and then get the additional updated information, I think what Sudarshan has suggested is probably the best approach.
Awesome. How should I approach prompting, tuning, training models for transforming documents that contain very domain-specific data? Jenny, you want to take that one?
Yeah, sure. If you look at prompting that we have for enrichments. Very soon, we're going to introduce a feature that allows you to change the prompt and its guardrails alongside the enrichments. So if you have super domain specific data that you wanted to do enrichments on, it is a feature that Unstructured provides. But if you think about what the main value proposition of Unstructured is, regardless of the domain of data that you have, we're just going to take that data and then transform it into the canonical JSON. So a JSON that you can repeatedly use and process over. And then whatever you're trying to do with the enrichments, that would be for the domain specific use case. Now, I don't care if you work in pharma or if you work in banking and healthcare, or even if you're in manufacturing. I just want to make sure that we're transforming and stripping out all of the text from the documents so that you can use it in your end reg application or a generative AI application or a agentic AI application. And so that is the role of Unstructured to really support you. Now, if you did want to take that data and go and train your own domain specific model, the canonical JSON that you have, like machines really like to work with JSON format, so you can definitely use that to go and train additional models.
Awesome. I think we're at time, but I think we can do one more question. So I want to talk a little bit about this. How does Unstructured handle performance and scaling with significant volume, both number of pages per file and number of files? So the platform in and of itself, like with the current SaaS machine types that we have, can process about 15 million pages an hour per workflow. And that's just arbitrary. Like if you were to include it in like your MVPC, you could choose a beefier machine type rather than the Azure CPUs we use, or like whatever the CPU machines we're using. And like you could boost those up. You could switch to GPU processing for everything. I wouldn't recommend that. That's very expensive, but you could do it. And you could increase that. You can also deploy multiple data planes, which is how we do GDPR compliance. And so for each data plane, about 15 million pages processed per hour. You can have as many data planes as you want. You only need a single control plane. That control plane acts as the orchestrator across those data planes. And so for us, we are infinitely horizontally scalable. It's just about the compute that's available to us. And we do a bunch of concurrency and memory optimization so we can handle any enterprise grade workload. Just really the value prop of Unstructured. We're here to provide production grade pipelines, partner with your ETL, partner with your data scientists and engineers so that you can help build the best generative AI products out there. Jenny, anything you'd add there?
No, I think you summed it up really greatly. I'm really excited to see what you guys are doing with the free trial that I hopefully you're going to sign up for after this. And if you do have any additional questions using the platform, please reach out to us, Slack community, or send us a direct email message, and we will point someone to help you with the use case.
For sure. And remember, we do have those like guided one-on-ones. Just reach out to unstructured.io/enterprise. But thank you all so much for the time. Really appreciate the attention. You've been an awesome audience. I had a ton of fun. Thank you, Jenny, for an amazing demo too.
Great. Take care, everyone.
Take care. Bye.